Now we start with the solution of example 5.1, which is the first example in this chapter with the title Cycloid Motion. So here, let me explain the example. What example this is? This is regarding the circular motion, and the circular motion is such that we consider that the particle is going in y direction. This speed v in the y direction, while the magnetic field is into the page. So magnetic field B is B, and this is in minus z direction. It is going into the page. Now what will happen is the particle is moving perpendicular to the magnetic field. So it will have a force which will be at this direction, because this force is supposed to be perpendicular to V and to B. So the only dimension that it will be is in the minus x direction, is it was here. And then what will happen? The particle is going in this direction, and the force on this particle is from here. It will be FQV cos B. F equals Q and V cross B. And this is F is equal to Q at G D magnitude at the sign of the angle between V and B. And we see here that this angle is 90 degree because the magnetic field is into the page and the particle is moving at this direction. So this is 90 degree here, and we have the charge on the particle, which is here, is Q here. So this is equal to F is equal to Q, and here I can write the direction of this as well, and this is in the minus x direction, means toward the center of this circle. So F equals Q B B, because sin 90 is equal to 1. Now when the particle was another step, so its direction slightly, you see that it is going in this way, but the force may compel it to not exactly follow its path, but slightly tilt, and so on. It will means this point will have the direction of V is this, and then here, and then here, and so on. So it will basically, it's a central force moves toward the center, just centripetal force. So it will accelerate it toward the center. It will cause, this means it will cause a force that is coming from the center of this circle, and the particle will start moving in a circle, and we call this thing is cyclotron motion or cycloidal motion or circular motion. So we have the magnetic force equal to this. Now the direction of this is in minus x direction because it is toward the center, but where the particle comes in here, at this point, now the force will be in this direction, because it's the force means it will compel it toward the center. So if every instant it will try to move it to the center, and due to its velocity it will go in a circular motion. So we have the complete direction along x or minus x, or it is toward the center. So we had the magnetic force basically equals PQ VB, and it behaves like the centripetal force. And the centripetal force means a charged particle, so it is having some mass as well. And this force is equal to the centripetal force, and I keep the centripetal force below it is mv square over the radius of this circle. So if, for example, the radius of this circle is r, then we have mv square over r equals q v and b. So this is the means both the forces will balance each other and the particle will be going exactly in a circle following a circular motion. So we have the this relation I can simplify is that if I cancel one v on this side and this side, then I can write the momentum, which is mv, equals to q, and this is p here, means the momentum here, and q, b, and r. So we have the momentum equal to this, or I can write this is LV, and here Q or B R. Means I can write it in many ways in order to do this. So the particle, if it is like I write like this P, and if the charge of the particle is known, the magnetic field is known, and the radius of the circle is known, I can calculate the momentum of the particle. Another way, if for example q is unknown and I know the momentum b and r, then means these things can very easily known because we know how much magnetic field we are applying, and then it will give us the nature of the particle, that what kind of particle is this. From here I can see that this is E, so I can write V over dr is equal to E over m. Because Q equal to E, the electronic charge, the electron is moving or proton is moving, then E over m. So charge to mass ratio I can easily find through V over BR. So this is a very simple example, and many parameters can be found from this thing. The other thing is that if we have the V exactly in this one, in this direction, but what if this will be slightly tilted, like it is this V here like this, so it is going exactly in y direction. But if it is slightly out of the plane like this, so it will have horizontal and perpendicular components. Or if it is tilted slightly into the boat, then again it will have the two components. So I can write that if V is not in one direction but it is slightly tilted, so it will have like this, and then it will have a component which we will call the V parallel and the V perpendicular component like this. So this will be the V perpendicular component and the V parallel component. It depends how I'm considering the tilt. So V parallel means this one is going in B direction, so we will have this V parallel going in the B direction. And what will happen here, when we will come here, when that direction will basically that component of the velocity will experience no force, because B and V are in the same direction, V parallel. So I can write that if equals, for example, I write for both separately, they Q and then V parallel in cross B. So this V paralleling is along the direction of B. And what will happen, there will be no force on this one. And the only force which will be here is Q V perpendicular. Only the perpendicular component will experience the force, and this will lead the non-zero force. And now what will happen here? Again here, we, for example, the if it is this is a three-dimensional, so kind of difficult to visualize, but I have drawn it like this. So what will happen now, that when you consider the carries the temp into the board, then this component will be V parallel and it will be along the magnetic field. And if you consider the out component, then it will be like this one. So when it is into the board, like for example, this is the plane and the V is tilted like this. So we have the velocity component which will be into the board, which will be along the direction of magnetic field. It will experience no force in that direction, and only the perpendicular component which will go like here, this way and this way. So that component, perpendicular component, will get the force. And what will be the result? Now the magnetic field or the force will now not be in the central direction, but it will try to move this in a circle, the force, but the perpendicular component of V will cause it to move against the magnetic field. Like it will follow a path like this one, that it will be like this, like the helical string here. So this will follow if the magnetic field is in this direction. So the V, the parallel component, then it depends B's, which we call the parallel and which we call the perpendicular. It will go opposite to that direction. So here that component will basically cause width and motion, and the circle will not be completed because it was, for example, on the plane here, and it was moving on the plane like this in the form of a circle. Now one component comes it which is giving it a push, and it will cause the circle not to complete, means the particle not to come exactly to its point from where it started, but slightly above it, and so on. And this will cause this particle to move in a helical shape, in a helical or spring type shape, and it will move upward or downward depending on the tilt that we are producing in the V. Means it tilts along that B direction or opposite to B direction, and it will then decide. We can draw a 3D figure, then we can easily understand the thing, but it is very hard to draw here. But with the help of some markers or pen, you can understand this direction or this helical motion easily. Now we say like this, that when if this V, which is here, I'm writing it in components, so a component, it will become easier. So if, for example, V is in the Y direction, means it will be along the Y axis, one component, and the other component along the magnetic field, and that will be in the z direction, which is the parallel component, like v is parallel to b, the component which is in the minus b direction, then this v perpendicular will cause, you will create circular motion, the v perpendicular, because this component, the one which will be along the magnetic field, will experience zero force. If it is against the magnetic field, then it will again cause a zero force, because v cross b, sine 0 is 0 and sine 180 is 0 as well. So it will, in both the situation, the parallel or anti-parallel component will experience no force, and the perpendicular component will be the one which will cause helical motion here. So this way, from a very simple geometry, we can have number of applications. For example, here we use the same tactics in accelerator. We can accelerate the particle, means we can increase its momentum with the help of QPR. Like we give a certain charge here, like electron is there, we apply magnetic field, we give it motion in a certain direction perpendicular to B for a maximum momentum, and then we accelerate that particle here. Similarly, we can determine the energy of the particle. If, for example, unknown particle comes in, then we can find its energy from P, like P square by 2m. It will give us the energy, and further, with the help of like E over M, we can find the E over M ratio. We can find charge on a particle if mass is known, or if charge is known, we can find mass of the particle. So by just changing some parameters, means some parameters is known parameters, the other is unknown parameter. So we can find the unknown parameters from the known parameters. And when this helical motion is there, is we cannot restrict particles moving in a space to go just along or applied magnetic field. So this can cause some trapping of the particles in space, which is usually this helical motion is caused, and they are not going in other directions, but they are trapped in a certain line here, means along the direction of the ecumenical path. So different applications can be done for this thing, and this is one of the simplest example of circular motion or cycloid motion.